Hi and welcome to challenge number 17, array rotation. In this challenge, our task is if we have an input like this, an array, and we have a number of rotations, for example, 1, what we do is we grab the last element and we move it forward. And we replace that. We replace the first element with the last one because we just had one rotation. So in the process, what we do is we shift all the remaining elements. So these elements, 1, 2, 3, they're going to be the remaining elements. We are going to shift it to the right. So the first position is empty and we put 4 in the first position. So that's array rotation. Let's go ahead and let's jump into JavaScript, the first language. And much like our other challenges for JavaScript, I'm going to go ahead and try to use as many built-in methods as there are as possible for arrays. So we have this rotate array. We're going to focus only on one solution because I want to talk more about the theory and how this rotation actually works in the context of these languages, rather than on the quantity of solutions. I just want to talk about the quality of each solution. So for any array, I'm going to do one edge case, and that is if the array is empty. And the way we can go about this is we're going to say if array.length is equal to 0, that means we don't have anything to rotate. So we would just return our array. Now that this edge case is over, let's actually go ahead and talk about how are we going to go about solving this. So we have a number that's called n. This n signifies the number of rotations. And we have our input array. Now, the first thing that I want to talk about or consider is what if n, the number of rotations, is larger than the array length. So let me just copy our entry, just put it here, and now let's talk about this. So I'm going to say n is equal to 1, and I'm just going to comment this out. So if n is equal to 1, we know that this is possible for us to rotate this item. We just grab a 4 and we put it in the place that belonged to 1. Okay, but what if n is 2? Well, then it means we are going to rotate 4 and then we are going to rotate 3. Okay, so let me just show it to you how this is going to look like. So if n is 1, what is going to be our array? Our array is going to go like this. Let me just visual so you can really see what is happening. So we have 4, right? But what if n is 2? This is very important for you to actually understand because all of our other challenges are based on this idea as well. So if n is 2, now you can see we already have one rotation, so we just add another one. And that means 3 is going to come to the front as well. So that's n2. But what if n is 3? So in this scenario, 2 is also going to come to the front. Now, something interesting is about to happen if n is equal to the length of the array. So what is the length of this array? It's 4, right? Let me write this. So length of the array is 4, right? This is the array length. But what is the n in the fourth iteration? N is also 4, right? Now let's see what happens in that scenario. So if n is 4, when n is equal to the length of the array, this should be 2. So here it is 2, sorry. So if n is equal to the length of the array stays the same. There we go. So is this, what do you think? This array and this array are the same, right? So this is something that we need to conclude. Now, what if n is larger than the length of the array? The first thing that you understood is that if length of the array, I should say array.length is equal to n, then what happens here? Well, what happens is array, basically we just return our array. Array stays the same, right? If this is the case. But what if n is larger than the length of the array? Well, we start at the beginning. So if n is 5 is actually equal to a value of n that is 1, right? So if n is 5, 4 rotations basically mean that array is the same, and you just add another rotation. So what happens in the other rotation? Well, number 4 is going to come to the front. So isn't this and this the same thing? They are the same thing, right? So if n is 5, that means n is equal to actually 1. So we just rotated by 1. Now, the reason that I did all of this is just to show you which operator we actually use. Now, we don't do this manually for all of our arrays because you might have several different arrays. We don't do this, but we need to come up with a formula. Now, you need to keep that in mind. So if you wanna come up with a formula, you need a pattern. Pattern helps you come up with the formula. So what is the pattern? The pattern is that if I grab n, right, and if I divide it by the length of the array, whatever is the remainder of my division, that's going to be the number of rotations that I'm going to end up with. All right, so array length is equal to 4, right? We know that. N is 5. So if I divide 5n by array length 4, well, what is going to be the remainder of that division? It's going to be 1. All right, let's say our n is 6. 6 divided by 4, which is the length of the array, the remainder of the division is going to be 2, right? Because there is 1 4 in the 6, and then whatever you have there, you just add it to the remainder, you need to get 6 back. So 4 plus 2, that's going to be 6. What about 7? You get 3. But what about 8? You get nothing. The remainder of the division is going to be 0, basically. So when you have 0, you don't rotate the array. The array is going to stay the same. And now that you know all of this, let's actually move on and write this. So we want to talk about the remainder of the division, and the remainder of the division is this modulo operator. So if I grab n and if I divide it by the length of the array, that's going to be the number of rotations that I'm going to end up with. And I'm going to say n is actually equal to n modulo length of the array. So if n is 1, 1 is going to be divided by 4, and the remainder is going to be 1. If n is 2, 2 divided by 4, the remainder is going to be 2. If n is 3 and you divide it by the length of the array, the remainder is going to be 3. So as long as it is less than the length of the array, the n that you get from the remainder of the division is going to be the same n as you got as the function argument. So we don't have anything to lose, but this formula helps us actually try to understand if n is larger than the length of the array. This formula helps us understand that and actually quantify that and not throw an error. All right, now that we have this, we just need to write one line of code, and that is going to solve everything for us. So we're going to use a combination of methods. So let's go ahead and let's just write our return. Now, what do I want to do here? Well, depending on what the number of n is, what the actual value of n is, I want to select those many elements from the end of the array. So that's very important. When we say array rotation, we select elements from the end of the array. So how do you select elements from the end of the array? Well, you know that in JavaScript, you just pass in a negative sign. So -1 is going to be the last element, which is 4. -2 is going to be the second last element. -3 is going to be the third last element. So if you want to select elements from the back of the array, from the end of the array, we just say negative. But how many elements do we select? Well, that depends on the array rotation. And what is that? That's n. So now you know what is this minus n. Cool. So which method allows you to select an item from the last element, grab it from there, slice it out, and just have it there. So you can just put it in the front. Well, we have this array slice method. So we have this array. On the array, we have the slice method. And the slice method usually selects the start and end positions. And it's not going to modify our original array, right? So if we pass a negative, for example, in our very first rotation, n is 1. In our very first test case, n is 1. That means 4 has to come to the front. This is going to be minus n, basically means minus 1. So we select the last element. So what is this going to return for us? This is going to return for us this. I'm just going to put it right here. This is going to return for us an array with just one element, and that's the element that we have sliced out of the array. All right. So this is what we have selected. So I have that. Now, what is remaining actually? Well, all the other elements are remaining. How do we select all the other elements? So I'm just going to provide some space here. Well, we could use the same slice. So let's use it. Now, programmatically, how do I know how many elements have I selected and how many elements are remaining? Well, I have this n. I have selected n elements. All right. So the other elements are actually remaining. So how do we put the remainder of the elements next to this n element? Well, we could say grab all the elements starting from position 0, and then all the way to negative n, because I've already extracted or sliced negative n, right? So this is going to give me all the remaining elements. But what is this available on? This is available on our array. Now, in here we have this 4. But if I just move forward in the comment, in here we have 1, 2, and 3. So how do we put these two arrays together? Well, we need to put 4 first, and then we need to append to it 1, 2, 3. So we combine two arrays. And what is the method that does that? It's the concat method. So I'm going to say concat, open this up, grab this, cut it, put it inside of the concat, and let's just save it. And that's it. That's it. We're done here. So I'm going to remove these comments. I'm going to remove this. I'm sure you understood that. So we basically sliced n elements from that array, and then we selected all the remaining elements and we concatenated the n elements to the start of that sliced array, and then we return it. That's it. Okay, so I have a few test cases here. I didn't want you to actually go ahead and watch me write all of this because it's very simple, right? So we're going to go over the test cases. In the first test case, we have, this is our input array. This is number of rotation. This is our function that we pass in the input array and rotate by. And we have just a few comments, so it's easier for us to read and understand this. In the second test case, we have rotation by 2. We have a different array. In the third one, we have a rotation that is larger than the length of the array. So you can see here, we have 4 modulo 3, but the remainder is going to be 1, right? This is not the result of the division. It's the remainder of the division, all right? So same as rotating by 1. See? So if you have 1 extra than the length of the array, that's rotating by 1. If you have 2 extra, 2 more than the length, that's rotating by 2. All right? And so on and so forth. We have this where we have just an array with 1 element, but we have rotate by 5. Well, this is just going to return the same element. And we have this, an empty array. Well, in this scenario, we just return an empty array. And what if our rotation is 0, while the array is going to be unchanged. This is in the scenario where you have a length which is equal to the number of rotations. You're going to end up with something like this. So if length is 4 and then number of rotations is also 4, then you're going to have an n which is 0. I know here I've actually specifically deliberately passed n as 0, but that modulo operation that could yield 0 as well if it's perfectly divisible. So 4 divisible by 4, 4 divided by 4, that's going to be a remainder of 0. All right. So if n is equal to the length of the array, n is going to be 0. And what that means is array is going to stay unchanged. Now let's go ahead and let's actually run this cd 017 tab. Clear. Just zoom it out a little bit so we can see everything at once, hopefully. Note a tab, enter. There we go. So what do we have here? We have our array 1, 2, 3, 4, rotation by 1, and you can see 4 is at the front. We grab the number of elements, the n elements, put them at the front, but the other elements, keep that in mind, especially for our other challenges. The other elements are going to be shifted to the right. We just shift them by one position. Well, not by one position, by as many positions as n states. Here we have this array, number of rotations is 2. So in the first rotation, 5 comes. In the second rotation, 4 comes and pushes 5 to the right. Cool. Here, 1, 2, 3, and then we have 4. Well, 4 is 1 greater than the length of the array. That means rotation by 1. And there we go. 3 is right here. So if you have just one array item, doesn't matter how many rotations, you're going to return that. If we have an empty array, it doesn't really matter how many rotations you have, you still have that empty array. And if you have 0 as your rotation, as your n, array is going to stay the same. Cool. Well, we're going to have all of these test cases for other languages as well. And now it is time for us to go ahead and get started with the TypeScript solution. And in my opinion, the TypeScript solution for this challenge is the most interesting one. And the first thing that I'm going to do here is create our function. This is going to be rotate array. What this function is going to accept is going to be an array. We are going to type annotate it to an array of numbers, but of course you can just come up with a solution for any type if you want. We're going to have our n, which is going to be the number of rotations. The type of this has to be a number. But what this function returns is going to be an array of the same thing that the function accepted. You could actually get away by making this a generic function as well, but I don't want to focus on that part. So the first thing that we do is we talk about the edge case, which we covered in JavaScript. And that is if the length is 0, we're going to return the same array. All right. Now, we need to talk about how to actually fix the number of rotations if they are more than the length of the array. So how did we go about this in JavaScript? I should just keep this open. In JavaScript, what we did was we used the modulo operator, and that gave us the remainder of the division, and we talked about it and we understood that, how that worked. But here, I don't want to use the modulo operator. I want to go a different way. So let's talk about this a little bit. The first thing that I want to mention is that a rotation in an array is actually cyclical. So what this means is after rotating 4 times in a 4-element array, we are going to be back where we started. So rotating by 5 is the same as rotating by 1. Rotating by 10 is the same as rotating by 2. Since we don't want to use the modulo operator, we need to come up with some other way, some other kind of operation that gives us the same result as the modulo operator, which was the remainder. Now, we could go ahead and actually subtract this. So if I have an array that has a length of 4, so let me just put it down here. Let's say array.length is equal to 4. I'm going to comment this out. And let's say our n is equal to 5. Now, when it is 5, it's just one more than the length of the array. And since arrays are cyclical, we basically go back to the rotation, which was 1. So if I go ahead and if I say 5 minus 4, this is going to give me 1. So a rotation of 5 for an array that has a length of 4 is the same as a rotation of 1. So this is 5 is actually equal to 1. All right, so it works for this one, and I should just provide triple equality. So you know that I know 5 is not equal to 1, but the rotations, if there are 5 rotations for an array that has a length of 4, that's actually equal to just 1 rotation. Because by the time that we have rotated our array 4 times, we are going to be back at the same array. And then once we add the 5th iteration, the last element is going to come to the front, and that is basically if you just have 1 rotation. All right, so what if the array has 6 rotations? So 6 rotations basically means that n is 2. 4 rotations is going to bring the array back to its original state, and then the other 2 are going to wrap around the last 2 elements to the start. So this could be our formula, right? So whenever you want to come up with some sort of formula, you need to find the pattern. Once you find the pattern, it's especially if it is like this kind of subtraction, addition, multiplication, or division, these arithmetic operations, these are very easy to come up with formula. So we could say if n is minus the length of the array, this is going to give me the new value of n. So let me just store it here. But this is only when n is larger than the length of the array. So what I could do is I could just say, let's use a while loop. I'm going to say if n is equal to, or if it is larger than or equal to array.length, then I want to do this. So if the length of the n is, if the length of the array is 4 and n is 4, that's 4 minus 4, n is going to be 0. Right? Because for an array that has a length of 4 and we want to have 4 rotations, the array is going to stay unchanged. So n is going to be 4. We're not going to rotate it even. And before moving forward, I want to create an array that's going to hold our result. Let result, which is going to be a type of number. This is going to be, and we are going to get started with an empty array. Now, we need to iterate over our input array, and we're going to see, depending on how many rotations the user or we have received in our functions, we need to bring those many elements to the start. Now, it was very easy if we were to do it with just some built-in methods. But since we don't want to use some built-in methods, we need to really understand what it means to bring some element to the start. So for that, what I would like to do is I would like to grab our input array right here. Let me just copy that, put it right here. And you know what? I just need the array. That's enough. So if I have a rotation of 1, what this basically means is the last element is going to come to the front right here. Let me zoom this in. So the last element just came to the front, but all the other elements, they're going to be shifted by the number of n to the right. So this is what I mean. So the last element came to the front, but the remainder of the elements, they were shifted by 1 position to the right. Now, in this scenario, since n is 1, the number of positions that you shift the remaining elements is going to be 1. What if n was 2? So if n was 2, we would also select 3 and we would put it here. So since n is 2, not only we wrap 2 elements to the start, we shift the other elements by 2 positions to the right. Cool. So this is how this actually works. Now, what we want to do is we want to do this programmatically. It's easier to talk about it, but it's going to be a little bit tricky if we want to actually calculate manually what is the number of n and how many elements we want to wrap to the start. So for this, let's just go ahead and let's have our for loop. I'm going to have 4. This is going to be let I is equal to 0, and then I is going to be iterated for as long as 1 less than the length of the array, and we already know why this is, right? So what we need to do is we need to find out where we put a new element and where a new element comes from. Now, there are 2 ways that you can go about this. You can either think about where does each element go, or you can go with where does each element come from. And for our example, we just talk about this array that has 4 elements, and then once we come up with the pattern and then the formula, it's going to be easier for us to implement that formula for any other array that we want to. So we need to come up first. We need to come up with the pattern. We need to find a pattern for this. So let me just say, what if we rotate this by 3? Then this should be 0. And then we have 1, and then we have 2, and then we have 3. All right, so if it is 3, 2 is going to come right here. And now this is going to be a rotation 3. And now what if rotation is 4? For an array with the same number of rotations as well as length, the array is going to stay unchanged. There we go. So this is how we progress. Now let's take a look at these 4s first. Where was the first 4? At the end. For rotation 1, it moved forward. Okay. For rotation 2, it moved backwards. Okay. For rotation 3, it came back. For rotation 4, it just went to and it became the last element. So if you take a look at this, I just select one element and I talk about that, but you can implement this on any of these elements. So 0, 4 is at position 1. Okay. If this is 0, well, 4 is at the same position. That's how I should go about this. But if n is 1, 4 has a position of 0, right? Cool. So index of 4 is 0. Okay, cool. I'm doing this because I want to show you how you can come up with the pattern for this. I'm going to copy this. Cool. Now, if n is 2, the index of 4 is going to be 1. Okay. If index of 4 is 1, and I can just go ahead and say index of 4 is 2 in this scenario, and index of 4 is 3 in this scenario. So take a look at these. So if it is 1, index of 4 is 0. If it is 2, index of 4 is 1, right? I hope I'm not confusing you here. If the number of rotations is 1, the index of the last element is 0. Cool. If number of rotations is 2, index of the last element is 1. So index of the last element will always be 1 less than the number of rotations. Okay, so I understood that. I know what happens here. Now, for each of these arrays, we need to take a look at the remaining elements as well. So if the index of the last element is 0, what is the index of the other element? Now, the reason that I'm saying this is because we're building this array position by position. So we know that in the first position of the array, if the n number of rotations is 1, this is going to be the last element right here. But if number of rotations is 2, it's not going to be the last element. It's going to be the second last element that's going to come to the front, because 3 in our original array is the second last element. And what I'm going to do first is I'm going to create the pattern for this array. We're going to then try to check that for the remaining rotations as well. And if the pattern applies and it works every time, then we can just convert that pattern into a formula. So let's go ahead and let's see how we can actually come up with the pattern. Now, we have 4 elements. We have 1, 2, 3, and 4. What is the indices of these? So I'm going to put the indices inside of square brackets. That's easier, right? That's the same notation. So we have 0, 1, 2, and what is the index of 4? You could say it is 3, but you could also say it's -1. So, but since I just want to keep this uniform, I'm just going to say it's 3. Now, if n is 1, this element that has an index of 3, it's going to change its position. It's going to come to the front of the array. And now the index of this is going to change to 0. And the other remaining elements, they're going to be shifted by 1 position. Now, keep in mind, for now, I just want to talk about indices because indices specify where each element of the array is going to go. I don't want to talk about the actual array element because for every array, that element could be different. For now, we just talk about the indices. So the element at position 3, it went to position 0, right? So what this basically means is, you know what? I should write it like this. This is easier. Just write it vertical. And the element at this position, I just want you to visualize this very well. So this is there. Let me just cut it, put it, cut it, put it here, cut this, put this here, and then finally cut this, put this here, and I'm just going to select this, and I have space there, so paste, paste, and then paste. This is better, right? So the position 0 got its element from position 3. Let me just fix this. So this should be 3, this should be 0, and this should be 1, and this is 2. So position 0 got its element from position 3. Position 1 got its element from position 0. Position 2 got the element from position 1, and index or position 3 got its element from position 2. That's if we have 1 for rotations. So you can see it's nicely moving forward, and it doesn't really matter if it is 1 or 2 because you do this cyclical. You do it once for the array, so once the array is rotated, then you rotate it again if number of n is 2. If number of n is 3, you rotate that again. So every rotation is going to look something like this. Now, let's not talk about the first one. Let's talk about the other elements. Let's talk about this position, and this position, and try to come up with a formula. So it was 1, and now it is 0. So I could, for now, let's just take a look at this. So I'm going to put that here, and I'm going to put that here as well. It was 2, now it is 1. It was 3, now it is 2, all right? As I told you, subtractions, multiplication, addition, and division, coming up with this pattern is simple. So we had 1 more than this, all right? So we are subtracting something, right? So it was 1, the position, and now it is 0, okay? It was 2, and now it is 1. It was 3, now it is 2. So it's always going to be 1 less than that. Right? And why is it 1 less? Because the number of n is 1. That's why we're subtracting it by 1. So this position, we have this position 1, and if I subtract it by -1, what do I get? I get position 0. And where is this coming from? So take a look at this. Isn't this the same position as this one? This is our formula, because we're looking at the pattern. And for the next one, we have 2. So we said 1 minus 1, and we got 0. All right? So if I say 2 minus 1, I get 1. So now you know where the 0 and these 1s are coming from. Well, what I should do is I should put these in between. So I should put it right here. And now you know how this works. Cool. Let me just copy this entire thing. Put it right here, and then I'm going to get rid of these. There we go. And you could just say this is an equality sign for you. And this is just one subtraction sign, right? So we have this 2. This basically means, let me just do it like this. We have 1, well, subtraction should be in the middle. We have 1 minus 1. That's going to give us a position 0. So this is going to give us a position 0. And what is the element as position 0? It is 1. Let's do this for the other one. So I'm just gonna copy this part, put it right here. For 2, it is 2 minus 1. So 2 minus 1, and this is gonna give us 1. And which element is at this position? Well, it's element 2. Cool. And let me just get rid of the index at the end of that because this is easier for you to really see it. I don't have it actually in my notes, so I'm just like speaking on the, from the top of my head, and that's why it's a little bit here and there. So I'm sorry for that, but I'm really sure that you can understand what I'm saying. You're following. So it is 3. Since number of rotations is 1, we are going to keep it as there, but we are going to say 3 minus 1. This is going to give us an index of 2, and an index of 2 basically means which element? Well, it basically means element number 3. So we have been able to come up with this. But what about this one? What about the first one? Let me just copy that, put it right here. So it is 0, 0 minus 1. What is this going to give us? This is going to give us an index which is minus 1. But we said, okay, the index of 4 is 3. But you know, if you just take a look at this index from the other way, it's also minus 1. So this 4 is also minus 1. It's 3 from the start, but from the end, it's minus 1. Cool. And this is going to give us the following element. Let me just copy this. So it is the same. It's going to give us element 4. So now you can see we are basically interested in this. This is our pattern. This is our formula. So if we have an array that is 1, 2, 3, 4, the length of which is 4, and we subtract the positions by the number of rotations, that's going to give us new positions. And then based on these new positions, we know where these elements are going to come from. All right. So take a look at this. Isn't this our final array? Isn't this the same as this one? So we have 4, and then we have 1, and then we have 2, and then we have 3. The only thing that we need to do here is to basically grab this and write it horizontally, and we basically need to keep the order. If the rotation was 2, we would have done the same thing another time. So we would get these, and then we are going to say minus 1, minus 1, 0, minus 1, and then, so you know, minus 1, that's minus 2, right? That's for this element. Because the index of 3 is, I know it's 2, but from the other way, it's minus 2, right? So it doesn't matter how many rotations there are, this formula is going to implement. The only thing that we need to do is we need to give these names. So this 1, we already know what that is. That is n for us. So very cool. Where should I write this? I could just say formula. We have something. I need to just put it right here. That's better. So we have minus n. What should I call this one? Well, you could call it whatever you want, but I'm going to call it our I. Why is it I? Because take a look at these iterations. It starts from 0, it goes to 1, it goes to 2, it goes to 3. The length of the array is 4. It never reaches 4. So isn't this the same as this I that iterates through our list or through our array? It's the same thing. So I could say I minus n. And the reason that I'm coming up with this formula is because what if the array has 5 elements or 10 elements or 100 elements? Once we have a formula, we can implement it on any array with any number of items and any number of rotations. So we know that this part, it looks exactly like our loop agent. It's 0 in the first iteration, and the second one 1, and then 2, and then 3. Since the length of the array is 4, 3 is always less than 4, and we can see that here as well. You can see 3 is going to be less than 4. In the latest iteration, or in the last iteration, it's going to be 3, but the length of the array is going to be 4, so this condition is going to be satisfied. So we know that this is I, but where am I going to store this value? The value that comes from here. Since these talk about positions, I need to store this position into some sort of a variable. And I'm going to just call it source index. Source index is going to be I minus n. Now, I could have just written this. Source index is I minus n. Whatever the number of rotation is, you can just subtract it by whatever the number of iteration is, you can just subtract it by the number of rotation. And that's it. Let's move on with this challenge. But I didn't. I actually spent time because I really care that you really learn these. You really understand what goes behind solving these. And you need to also appreciate the built-in methods that these programming languages they have. So you just have one line that does all of this, but then if you just go ahead and write it manually, you have all of this logic that you need to pay attention to and come up with. So now that I have this, let me just initialize this as well. We're going to use let because this is going to change for each iteration. Now, there is one other edge case that we need to talk about here. But first off, I want to store this element inside of our new result array, and then I want to talk about that edge case. So whatever the iteration is, depending on where the iteration count stands, we're going to grab our array and we're going to store the element at this position. So what does this mean? It means, let me just zoom this out a little bit. It means if we are in the first iteration, that means I is 0. So I is 0, right? It is minus 1, since we say I minus 0 minus 1 is minus 1. So what this returns is going to be minus 1, right? And minus 1 is the index of which element in this array? It's the index of 4. So the first element that we copy to our results array is the element that has an index of minus 1. And which element is that? Well, it's 4. So we just copied 4 in there. And we're going to add a comma. Let's go to the next iteration. Next iteration, I is 1. Okay? And we said that this is 1. N is also 1. So 1 minus 1, that's 0. 0 is the index of which element? It's the index of this element, this 1 right here. So we grab this 1 and we copy it right there. Let's move on. In the next iteration, the I value is going to be 2. 2 minus 1, that's going to give us 1, right? Which element has an index of 1? It is this, number 2. So let me just write it there. And then let's go to the next iteration. And the next one, I is going to be 3. It still satisfies this condition. So we come right here, it says 3, 3 minus 1, since n is 1, we get 2. And what is the element present at position 2? It's this element, which is 3. So let me just copy that and put it there. Let's move on to the next iteration. In next iteration, the value of I is going to be 4. Will this condition be met? No, because we said for as long as I is less than the length of the array. Since length of the array is 4, 4 cannot be less than 4. I is 4, length is 4, 4 cannot be less than 4. So this loop is going to wrap, and that's it. So what did we end up with? We ended up with 4, 1, 2, 3. But there is a problem here. The problem is that even though we talked about this index, which is minus 1, in JavaScript and TypeScript, we don't have an item positioned at this index. The indices in JavaScript and TypeScript, they cannot be negative numbers. They can only be positive numbers. Yes, you can say the last element of an array is minus 1, but unfortunately, you're not going to be able to access that by just saying minus 1. And what do I mean by that? So let's go ahead and let me show you all of our test cases so far. I did tell you that I want to talk about an edge case. So I'm going to put the test cases down below, save this. Now, we seem to have one error, and the reason for that is we're not returning anything from this function. We need to return an array of numbers. So this is perfect, right? Let's go ahead and run this. I'm going to say TSC B tab, enter, and then node B tab rotation.js. Let's hit enter and let's see what the problem is. There we go. So if we have a rotation that is 1, we can see the first element of the newly created array or the output array is undefined. But the other elements, 1, 2, 3, are defined. Which one is this element? It's this 4, right? So 4 is undefined because we're trying to access -1. And then if the number of rotations is 2, we have 2 undefined. It's the same thing. If the number of rotations is 1 more than the length of the array, we just have 1 rotation, therefore we just have 1 undefined. And then take a look at this. We have some unexpected behavior here. We just have 1 element. If you rotate it, it doesn't matter by how many times, we should just end up with 1. And these 2, they behave expectedly. But take a look at this undefined. This is something that we need to talk about. So we need to refine, we need to refine our formula so it works with these edge cases as well. Now you can see our formula doesn't work all the time. It needs to be refined. And how do we refine this? Well, there is like a couple of ways that we can go about this. And what we need to do is we need to make sure that this subtraction, it shouldn't be below 0. It shouldn't go below 0. In our very first iteration, this is going to be, let me just select it. This is going to be -1. And when it is -1, that means the last element of the existing array. So let's fix our formula here. So if it is -1 in an array that has a length of 4, this should be actually 3, right? So now you understand where this comes from. And we are going to refine our formula in just a moment. Let me just write all of these. So here, let me just bring it back. So if it is 0, this means it still is 0, and this is still 1, and this is still 2. So we don't change the other ones, we just change this one. So how do we go from -1 to 3? Well, let's take a look at this. So we have -1. The total length is 4. So 4 minus 1, that's going to give us 3, right? We want this to only work if the index that we have got from our subtraction here, aka the source index, is -1. That's when we want to do this. We don't want to do this for all of our operations. So what I can do is, I said if, so I'm going to use an if statement. I'm going to say if source index is less than 0, well, that means it's negative, and we need to convert it to positive in order to access the element correctly in JavaScript and TypeScript languages. So if it is less than 0, now we need to first come up with the formula here. The first formula was this one, and let's talk about the second one. So for the second one, we have a source index that's negative, right? So we have a source index that's negative. So now we know that if our source index is negative. But do I really need this negative sign here? No, I don't, because within the if statement, I've already stated that the source index is going to be negative. So I don't need this negative sign. Now, if it is negative, that means basically -1. And what should I add to -1 in order to get this position? I'm going to add 4 to it. And 4 is the length of the array, right? And we're going to check that in the console as well if that works for the other arrays, for arrays that have a length of 5, 6, whatever. So here we have our source index plus the length of the array. What is this going to give us? Well, let's take a look at it. Length of the array is 4. Source index is, in the first iteration, -1. -1 plus 4, this is going to give us 3. There we go. So the first element that we put inside of our result array has an index of 3. Which element is that? It's element number 4. The element or the item that is called 4. So in this scenario, we're not going to end up with an undefined. So we need to have our source index plus the array length, but where do we store this variable? Well, we store it as a value for source index itself, because source index is the index of the element that has been repositioned, whether it was shifted to the right or whether it was basically rotated from the back and it came to the front. All right, so let me just grab the source index, put it right here as well. And then this is going to be the new value of source index as well. And there we go. And that's it. We should be done here. We need to check this for other arrays as well. First off, let's transpile it and then run this. And there we go. So if an array has 4 items, it means the length of the array is 4. We rotate it by 1. The last item is going to go to the front, right? But if an array has 5 items and we rotate it by 2, the last 2 elements cyclically go to the front of the array. So we grab the last item, we put it, and then the second last item, and then we put it. And there we go. But if the length of the array is less than the number of rotations, this basically means that we're going to subtract the number of rotations by the length of the array, and then we're going to rotate it by that number. So 4 minus 3, this array has 3 elements. Rotation is 4. 4 minus 3, that's 1. So our rotation is going to be 1. So we grab one. We basically grab 3. We bring it to the front. But now here you can see we have this problem again, and this 3 should have been moved to the front, and we still have this 5. It should just produce 1. It shouldn't have 1, 2, 3 here as well. So let me take a look at my code. Let's see what the problem is. So we said if source index is less than 0, this part worked. So I'm pretty sure that the issue is not in here. Let's see. So our source index is I minus 1. This if statement, the problem with these, this 4 and this 5, it didn't have anything to do with our if statement. In the previous log, we had these problems as well. So source index is, oh, I have something inside of my array. Let me just get rid of it. There we go. And now let's go ahead and let's run it. Hopefully now it is fixed. Yeah, perfect. So our array had some items inside of it. And now let's take a look at the first one. Perfect, right? Let's take a look at the second one. Correct. For this one, we just bring the last element to the front. For this one, we don't really do anything because there is just one element. And if you have an empty array, you get an empty array. If there is no rotation like this, you're going to have your array unchanged. Very good. So this formula actually worked. So I did really spend a lot of time on this one just to make sure that you understand. I just wanted you to understand where I minus 1 comes from. And I also wanted you to understand what source index plus array the length comes from. The rest, this part, these 2 lines, these one, and also this formula. So 2 subtractions and 1 addition. I just wanted you to know that where these actually came from. And now that you understood this, you can actually try to implement this in other challenges as well. So what you do is you find the pattern. After you have found the pattern, most of the patterns that you're going to find, they're going to be very easy. So it's some sort of a subtraction or multiplication. You can overcomplicate them, of course, but you try to just break them down into their like consisting parts. So all of the operations, they have a basis in subtraction, multiplication, addition, and division. That's why you study them first. You study arithmetic, and then you go to algebra and move forward. So all of these, they have their base in these 4 basic operations. So if you just grab your pattern, just find the pattern, try to translate it into the one of these four or a couple of these or whatever, then you can just write it and you can fix it. So if there are any issues, like issues that we faced, we were able to fix it because we knew what the issue was, right? So once you know the pattern, finding the issue is also very simple because you can trace your steps backwards. So we had this here and we understood, okay, the problem is this -1 because 0, 1, and 2, they produce their numbers, but this -1 produces an undefined. So let's fix this. So instead of -1, let's pass in 3, which is the index of the last element, to this array and just populate it like that. But then how do you get 3 programmatically? You get it like this. So this is how you can go about this, and this is exactly what I mean by these challenges being just practice for your programming. And I shouldn't call them math skills because these are very simple, but they are generally a practice for your programming skills. And with this, I want to wrap this solution up and I want to move forward with our video. So I want to keep this JavaScript solution open. Let's move on to the Python solution. For Python, we're not going to overcomplicate this. We're going to try to make it as Pythonic as possible. And to get started with the Python solution, let's go ahead and let's define our function that's going to be rotate array. What is this function going to accept? We already know that it's going to accept an array and the number of rotations. So what do we do first? Well, we first check for an empty array. So we're going to say if length of the array is equal to 0, we return the array itself. So we're going to return a copy of the array. And this is the Python slicing index. Sorry, not index, syntax. This is the Python slicing syntax that we can use in order to make a copy of the array. So what is this actually? This is a colon. And when we don't have a start and an end, so what is on the left of the colon? That's the start of your slicing of the array. And what's on the right, that's going to be the end of the slicing. If we don't have any start, we don't have any end, this is just going to default to the beginning and end of the array itself. So it's basically like grab all the existing elements from the array. Now, here we have this condition where if the length is 0, well, we don't have anything to rotate, so we just return that empty array. All right, but what if the number of rotations is 0? Now, for an array that has a length of 0, it doesn't make sense that we return this colon because there are no elements to start and end with. But what if the number of rotations is also 0? So if n is 0, do we rotate the array? No, we don't have any number. So the array is going to stay unchanged. So that's why I'm going to add an OR logical operator. And in here, I'm going to say if n is also equal to 0. So what this basically means is if any of these conditions becomes true or yields a Boolean true, then this if statement is going to run. But this situation is not like both of them have to be true. We say either length is 0 or n is 0. Then we return this. Cool. So let's move on. Now, since we are in Python, this is extremely simple for us to implement here. And I'm just going to go ahead and I'm going to show you how we go about this. So for this, I need to grab one array from here. I have this array, this one. This is very good. So I have this array. Let me just copy it. And I'm going to go outside of the function, just paste it right here. So for this one, let's say the number of rotations is 2 because it is 2 here, right? So what does this actually mean? It means I have an array that is going to contain 1, 2, 3. I could say this, right? And then I have an array that could contain 4 and 5. Why 2 elements? Because the number of rotations is equal to 2. So we select 2 last elements, all right? Let's move forward. So what do we do with this? Well, we grab this, cut it, and we put it at the start, and then we say, okay, this is how this is going to be rotated. So I have the last 2 elements at the start, and then the remainder of the elements to the end of the array. Depending on the number of rotations, those many positions, they're going to be shifted to the right. So now what is going to be the last operation that I'm going to do? It's going to be to combine these two arrays like this. So we could go like this, right? And this is exactly how we're going to go with this solution. So the first thing that we need to do is extract n elements from the end of the array. Why n? Because n is the number of rotations. So if n is 1, we extract 1 element from the end. If n is 2, we extract 2 elements from the end. But we need to do this programmatically, so we don't hard code the number. So n elements from the end. And using this Python's slicing syntax, we can do that. So let me just copy that, put it down here. So how am I going to select n elements from the end? So as I said, on the left of this colon, you provide the starting index. On the right hand side, you provide the ending index. Now, since we want to select n elements from the end, we don't want to specify the end, because we want to select whatever there is in the end. So this right hand side is going to stay as it is. We're going to default to the end of the array itself. But where is our starting point? Well, we know our starting point is n, because that's going to specify how many elements we want to select, right? If n is 2, right here, we selected 2 elements, 4 and 5. If n is 1, we select 1 element. But we talk about an array and the selection of items from that array from the end. And as we talked about this in TypeScript, in TypeScript actually, Python has this ability to help us with negative indexing. In JavaScript, TypeScript, we don't have it. That's why we came up with that formula. But in Python, we have that. So what I can, since I'm talking about end, I'm just going to pass an n, a negative n. So give me negative n elements from the array. Negative basically states that I want from the end of the array. We want to select elements from the end of the array like this. So what I basically did is this is the same as this. We select n elements from the end. And then what did I do next? I said plus. So let's add a plus. And now I need to select the other elements, right? I can do that using this as well. So I want to select elements from the start of the array. Keep in mind, 1, 2, 3 is start of the array. So how do I select it? This is start of the array. Now, how many, we can provide the start of the array, right? If we want to have the start of the array, you can just leave it empty, and the slicing and syntax is going to select the first element as the start. But where do we end this? We don't want to select all the elements because we have already extracted n elements from the end. So where do we end this? Well, we end it exactly at n elements. So this thing right here, as stated previously, is equal to this, and start with the start of the array, but end right at the nth element. Why don't I say second element or third element? Because for each testing, that's going to be different. So this is going to select these 2 elements, and this is going to select these 3 elements. And now let's go over this one more time just to reiterate and make sure everything's clear. In this scenario, what we say is we say select elements from nth position from the end. All right. And then we select it from the end to the end. So whenever you have this Python slicing syntax, you need to provide a start and an end. If you don't provide an end, this is going to default to the end of the list. That's clear. All right. And this is going to give us n elements from the end of the array. But then we want to put this in the front and put the front elements in the back. And this line basically states we want to grab elements from the beginning up to, but not including, nth from the end. And this is going to give us everything except the last n elements. And that's it. Very simple. And finally, let's return this. There is one more thing missing, and that is what if n, the number of rotations, is larger than the length of the array? We have already talked about that in JavaScript, so we are just going to use the same method. Syntax is a little bit different since we're in Python, but the idea is the same, all right? So here is the solution for Python. As usual, the simplest and smallest solution. I already have created our test cases, so I'm just going to go ahead and copy paste everything here. We have 6 test cases. You can take a look at these. And now let's go ahead and let's run this. I'm going to say Python C tab, enter. And now let's check each of these one by one. For the first one, we have a rotation of 1, where we can see 4 has come to the front. For the second one, we have rotation of 2, where we can see 4 and 5 are in the front. And for this one, n is larger than the length of the array, so it's larger by 1, right? That's the remainder of the division, and that would basically mean that we just rotated by 1. Cool, and there we go, we rotated that. If it doesn't matter how many rotations we have, in our next example, if there is just one element, we just return that. It's not going to make any difference. If it is empty, then we are going to return that. And if the n is 0, we're going to return the array unchanged as well. So that is going to be it for the Python solution. Let's jump into the Go solution. The Go solution is going to resemble a lot that of the Python solution. So the first thing I'm going to do here is I'm going to import our main package. Let's go ahead, let's create our function. This is going to be rotate array. And this is going to accept an array that is going to have elements as integer type. And then the n, or number of rotations, is going to be the same thing, the same type, integer. But what we return from this function is going to be the same thing as what the function accepts as the input array. So what do we do here? The first thing that I'm going to do is I'm going to say if length of the array is equal to 0 or n is equal to 0, then what do I want to do here? Well, I just return the array. That's it. I don't want to do anything else. Now, let's go ahead and let's fix n. If n is larger than the length of the array, we use the modulo operator to get the remainder. And the remainder, as stated previously, is going to give us the number of rotations. Since array rotation is cyclical, this is going to work perfectly fine. And now for our actual solution, the first thing we need is to actually create, using short variable declaration, a new array. We're going to use the make method. So what do we want to create? I want to create an array with a type of integer, but the starting length for this array is going to be 0. There we go. And about the solution, well, as I said, it's going to be like the Python one. So we select n elements, we put it at the start, and we grab all the other elements which were previously in the start, we push them to the end by n elements. That's it. That's going to be the solution. So for this one, we're going to grab the result and we're going to use the append method, right? So I want to append to the result. What do I want to append? Now, the first thing that I want to say here is you need to unpack or spread these items. So if you're coming from JavaScript world, unpacking in Go is the same thing, 3 dots, as the spread operator for arrays in JavaScript. What it means is these 3 dots, they're going to take away the syntax of the array and they're going to unpack or spread the items here so we can grab these items and put them or append them to our results slice. All right. Now, how do we actually do this? Now, this is just the unpacking operator, but where are our elements? Well, we need to specify where they are and then we need to unpack them. So let's go ahead and let's specify that. Now, where do we select the elements? So at the beginning, what we want to do is we want to select all the n elements from the end and then put it at the start. So how do you go about this? Well, how do we know which elements are those? So for that, I'm just going to create a few comments here. So let's say our array length is equal to 5, right? The same example for Python. And our rotation is 2. Let me write n is equal to 2. So length is 5, n is 2. How many elements should I select from the end? I need to select 2 elements. And if I select 2 elements from the end, how many elements are going to be remaining? 3 elements, because 3 plus 2 is going to be 5. So it is safe for me to say, if I grab the length of the array, and if I subtract it by the number of rotations, so I'm going to say minus n, this is going to give me the number of elements that should be shifted to the right. This is going to give me 3, right? So what is the length of the array? The length of the array is, let me just write it here in the next line. This is 2. Length of the array is 5. 5 minus 2 is going to give me 3. So now I know exactly how many elements I need to bring to the end, and then how many elements I need to bring to the start. All right, so if I were to pass this 3, let me just create another comment. Let's say we were to have the same slicing syntax in Go. I would have to pass in 3 to end, right? Because this is going to select elements from index 3 to end. Now, one thing I actually forgot to mention is that when you have this slicing syntax, the starting index, the index that you pass at the start, that's going to be inclusive. So when I say index 3, now, what is our array? Let's first just take a look at our array so we can see how this actually works. So here, let's pass it there. So what are the indices of these elements? Let me just write the indices here. The first one is 0, then I have 1, then I have 2, then I have 3, then I have 4, right? These are the indices of these elements. Let me just get rid of the comma so it is aligned. There we go. So if I say select item from the index of 3 is this item, which means 4, and then select go to the end. What is the end? The end is 4. I said the start is inclusive. So when I pass in index 3 is going to be included in my new array. That's going to be included. So it's not like start from 3, but don't actually include 3, include 4 and beyond that. No. Starting index is included. So I'm including 3 and 4. Which elements are present at these 2 positions? It's element 4 and 5. So I am already selecting element 4 and 5. Why do I select element 4 and 5? Because n is 2. So the last item is 5 and the second last item is 4. So I need to select 4 and 5. And I just did. I selected their indices 3 and 4. So this effectively gives us last n elements. Cool. Now these last n elements, they come to the start. But what goes to the end? Let's calculate that as well. So what goes to the end is going to be the remaining elements. Now, what are the remaining elements? Well, we need to do this programmatically, right? And we have already done that. We have already done that right here on line 16. So what do I mean by that? So we already know length of the array is 5, n is 2. And we said, okay, if length of the array minus n gives me 3, that means I'm selecting the last 2 elements and I'm moving forward. Then the remainder of the elements, however many there are, I don't know how many elements there are, like programmatically speaking, if I just say n and length of the array, and if I have like 1,000 input arrays and I don't take a look at them and this operation just runs, I don't have no idea what is the length of the array which is at position 125. I have no idea. I just want to write the formula. I want to find a pattern so I can write a formula, and then the formula is going to do that for me. So I have already selected all the end elements, moved them to the front. The only thing I need to do is move the front elements to the end by n, all the way to n, but not including n, because n elements have already been moved to the front. So how do I do that? Well, what I'm going to do is the same thing. I'm just going to pass in 3. This is exactly, so this 3 is the same 3 as here. This is our n, right? This is what we actually, this is not our n because n is actually 2. This is what we subtracted from the length of the array. So from the length of the array, from the subtraction, we got 3, right? And this 3 came here, and the same 3 came here. So what does this mean? Now I need to write this. Start is inclusive. And then I'm going to grab this and I'm going to put it here, but end is exclusive. That's the good thing about this method. Now, if I say the start, now here, take a look at this. I'm not passing anything to the start. I'm just passing an index to the end. And I say end is exclusive. So what does that mean? It means select all the elements, select all the elements up to, but not including index 3, excluding index 3. So it's going to select like this. It's going to say 3. So I'm selecting index 0, then 1, then 2. But the end index for me is 3, okay? And I know end is not inclusive, it's exclusive. So I'm not going to select it. I'm just going to hit the brakes here. So it's going to give me indices 0, 1, 2. Which elements are present at these indices? 1, 2, 3. So effectively, 1, 2, 3 is going to be moved to the end. And this is very cool. The same thing is in Python. I just forgot to mention this. We have the start, which is inclusive, the end, which is exclusive. Even though we have passed index 3, it's not going to select the element present at this index, because the end index is exclusive. All right. Now, if you were to pass 4, that would select an element at the index of 3, but then it would not select the element present at the index 4. All right. And so we need to come up with this, We need to write a formula that does this for us. And congratulations, we have already written that formula. It is length of the array minus n, and that's it. So we need to pass in this length of the array minus n to this slicing syntax, to the start of it, for getting the n elements from the back, and then again to the back of this for getting all the elements from the start. So it's like the reverse, right? But the idea is exactly the same as Python. So we have this for starting, we just pass in this. Why do we pass in this? Why don't we pass in just 3? Because the next array could have 100 items. So and n could be like 50. So am I selecting 3 elements? Am I starting at index 3? No, I'm not. I'm starting at index whatever, 50, 49, right? Or 51 rather. So I'm starting at that index. The reason we write it like this is because this is flexible. So this is going to be the start of the end of the elements, like n elements, but then the end is going to be the end of the array. Now, if I don't pass an end after the colon, that's going to be the end of the list automatically. And why is this a good thing? Because if an array has 10 elements, the ending index is 9. So I need to write 9. If an array has 100 elements, the ending index is 99. If an array has 25 elements, the ending index is 24. So should I change this every time depending on the length of the array? Or if I just leave it blank, this algorithm is going to calculate it for me and I don't have to worry about it. So I'm just going to leave it blank. Now, what this does is, let's just go over this. This, you already know what this is going to do. This is going to give us elements 4 and 5, but inside of an array, right? And then this is going to give us elements 4 and 5, we convert them to an array using the array, and then these 3 dots are going to unpack them. And this result is going to look like this. So let me just copy paste it for you. So this is going to be in the first operation, in the first step, this is going to be 3. In the second step, this is going to give us an array like this, 4 and 5, but an array. And in the next step, this spread operator is going to unpack it. This unpacking operator is going to unpack it. And finally, this append method is going to append 4 and 5 to the start of this result. I'm going to comment these ones out so you can have it as a reference. The same thing is going to happen for the other one. So we have selected the start. Let's select the end. So where did we pass this length array minus n? We passed it to the end. So let me just cut it, put it at the end, and that's it. That's basically it. The idea is the same thing. Now, we have an error because we're not returning anything. So we need to return a result. That's it. I did explain it a little bit more because I just want you to really understand what is happening here. So let me just copy my main function, just a series of print statements. Just going to put it here. We need to import fmt, and then that's it. Clear. Go run the tab, enter. Wait a few seconds. There we go. Now let's take a look at our results. So here we have this array. Rotation is by 1. And then what do we get? We get 4, 1, 2, 3. Cool. Here we have 4, 5, 1, 2, 3 because rotation is 2. Here we have length is 1 more than the n is 1 more than the length, so we get just 1 because it is 1 more than the length. We have already talked about that. So here we don't do anything because there is just one element. Here the array is empty. And finally, the n is 0, and the array is going to stay unchanged anyway. And that is it for the Go solution. Very cool stuff, right? And the final language that we're going to jump in and talk about and solve this is going to be Rust. So the first thing that I'm going to do for Rust is create our function. It's going to be rotate underscore array. What is this function going to accept? It's going to accept an array of numbers, or in Rust, we just call it a vector. So a vector that has items as integer 32, and we have our n, the type of which is going to be usize. This is unassigned size, and we need this type because we use this n in order to find out the length, in order to find out the end, basically do some indexing, and it has to be this type in Rust. So what do we return? We return a vector of the same type, i32. Very cool. For our very first case, we're going to say if array is empty, is underscore empty, or if n is equal to 0, what do? We basically return the array itself. And one more thing about this usize, it can never be a negative number. It can only be 0 or greater than that. Because if we have a negative number and we want to index through a collection in Rust, that's going to throw an error for us. So we need to prevent that. Next up, let's fix the value of, or the number of rotations. We are just going to say array.length. We have already talked about this. And finally, the way that I'm going to go about this by solving this is going to be using an iterator chain. And an iterator chain basically means you are going to combine several methods together. So the first thing before jumping and creating the iterator chain is I need to know where I'm going to basically provide that cut. Where am I going to separate or split or slice the number of items or elements that I want to bring to the front and the other items that are going to go to the back. So we need to have some sort of a slicing situation here as well. And we could call it a slicing or splitting point. I'm just going to call it slicing just to stay consistent. That is going to be our array. How did we find it in Go? We said array.length minus n, right? That's how we found it. And that's exactly because it is a formula. It works in any programming language. It's a formula that's independent of the implementation that you want to do. So this is going to give us the splitting point. And what this means is the elements that we use from this point to the end, they are our n elements that should come to the front, and the elements that we use from the start up until this point are the elements that need to go to the back. Cool. So let's go ahead and let's create this. So we're going to say array. I'm going to first grab our array and I'm going to convert it into an iterator over references, right, to elements. So how do you do that? Because we want to iterate over it. So I'm just going to say this is going to be dot error. And you know what? Let's just go ahead and chain it on. So what do we want to do? Well, the first thing that we want to do is we want to skip the starting elements and just talk about the ending elements because they are going to come to the start. So we use the skip method and we pass in our, that's slicing point. So we select this slicing point. So we basically ignore the start of the list or the start of the vector, and we directly jump into the last n elements. So if n is 2, we talk about the slicing point is just going to have 2 elements at the end. So we skip all the others. What do we end up with? Well, we end up with only 2. And then once we have selected the only 2 last elements, let's chain it to the front of the other starting elements that we have shifted now to the right. So we skipped over the starting elements, we selected the last elements, and then we should bring it to the front and then put it or chain it with the other elements. So it's like elements 4 and 5 have been selected. We need to bring elements 4 and 5 to the start and chain it with 1, 2, 3. So how do you do that? We grab our array, we iterate, make it convert it into an iterator, and we are going to call the take method on this. We're going to pass it our slicing point. And this take method is exactly like our skip. Skip skips the starting elements up until the slicing point, but take is going to take elements up until the slicing point. All right. So you can think of these like this. So we had an array, we passed in 3 to the start, we didn't define the end. You could say this is the same as this, right? And then we had this one, take. You could say this is the same as this one. So we already talked about this and this in our Go solution. So these two are the same. But what chain does is it chains 2 iterators together. That's why we needed to convert it to an iterator first, then be able to chain it. Now, what do we want to do next? Well, since these are references, let's go ahead and actually convert them to values. And we do that by using the cloned method. And finally, let's collect them into a collection or into a vector. Let's zoom this out. Maybe too zoomed out, zoom this back in, and there we go. We are effectively done. Save this. Let me just bring the solutions. I have already created all of the solutions, all of our test cases. Just copy paste it here. We're going to run it and we're going to see if there are any errors. So this is going to be Rust C, E tab, enter. Good, nothing. That's very good. And now I'm going to run the exe file, array rotation. And there we go. Let's see what is happening here. So here we have our original array. Rotation is by 1. We can see 4 is to the start, which is the skipping part. And then 1, 2, 3 is the taking part. Cool. Rotation by 2. 4 and 5 are the skipping parts. 1, 2, 3 are the taking part. So we have 4, we have just 1 rotation, 3. For 5, it's the same thing. For 3, it's again the same array. And if number of rotations is 0, the array basically stays unchanged as well. So with this, the solution has come to an end. I really hope that you enjoyed it. And for me, this was rather really interesting. I would say even a little bit more interesting than the other challenges in this series 11 to 20. So with this, our video comes to an end. See you in the next one.